Hello everyone, and welcome to this series of training lectures about the OpenLI lawful intercept software. My name is Shane Alcock, and I am the lead author and maintainer of the OpenLI software. I'll be guiding you through this training, which is designed to teach you everything that you need to know to be ready to deploy OpenLI on your network. Before we begin, please note that we welcome any feedback, suggestions, or questions about this training. You can reach us at openli-support@waikato.ac.nz, or you can reach out to me directly if you prefer. The training is split into multiple short chapters, and this first chapter will introduce you to the topic of lawful intercept. Here we'll be looking at lawful interception from a fairly general perspective, so this chapter will be useful to anyone who is new to the topic of lawful intercept and is wondering just what it is all about. We'll touch briefly on OpenLI, but the main aim in this chapter is to simply familiarize you with how LI generally works and the terminology that is used to describe the different parts of an LI system. We'll delve into the more specific details in later chapters, but feel free to skip ahead if you feel like you already have this background knowledge. So what is lawful intercept, or LI as it is commonly known? It is a tool that governments provide to law enforcement agencies, or LEAs, that allow these agencies to perform a legal, pre-authorized interception of telecommunications. The interception target must be a person or persons resident within the jurisdiction of that agency. Interceptions may be undertaken as part of an investigation into or as part of the prevention of illegal activities. Agencies that typically have these powers include the police, intelligence services, and national security agencies, but other agencies or ministries may also have these powers depending on the law in a given country. In most cases, however, these agencies do not have the ability to directly action an interception on their own. They instead rely on the network operators who run the communications infrastructure to capture the target's communications and forward those on to the requesting agency. The operator is legally obliged to assist LEAs with their interceptions and must ensure that their network is ready and capable of performing such intercepts on demand. A key thing to remember here is that lawful interception must target a specific user or set of users that the agency has a good reason to believe to be involved in criminal activity. So we're not talking about dragnet style mass surveillance here. In most cases, an intercept can only take place if the interceptor request is accompanied by a lawfully issued warrant. However, the authorization powers for a warrant can vary quite a lot between countries. Many countries will require judicial or magisterial oversight, but in other countries a warrant may be approved directly by a chief prosecutor or a sufficiently highly ranked police officer. And in a few rare cases, warrants may be approved by government ministers. It therefore pays to be aware of the exact circumstances surrounding the issue of interception warrants in your jurisdiction, and this will allow you to know exactly when you have to comply with an interception order, as well as when you might be within your rights to refuse to carry one out. Be aware though, the laws that give interception powers to the agencies will include severe penalties for operators that fail to give assistance when required. This also means that it is especially important for operators to have some LI infrastructure in place and tested well ahead of time, as you really don't want to be the one operator that the agencies decide to make an example of. So let's walk through how this all works in practice at a high level. An interception begins with an LEA identifying a target, getting their warrant, and then issuing the warrant to you, the network operator. The specifics of how the warrant is issued to an operator will vary from country to country. It may involve a physical piece of paper with a written signature on it, or it may be a digital artifact. Using the details provided within that warrant and their own understanding of how the target identity would map to a customer account within their system, the operator will then configure their LI system to commence intercepting the communications traffic for the intercept target. For now, we're simply going to think of the LI system as a magic box. It could be an OpenLI deployment, it could be a solution from another vendor, or it might be something that you hacked up in-house. For now, this doesn't really matter too much. To be able to perform the intercept, the LI system will need to be able to see the traffic that traverses your network so that it can recognize which packets belong to the intercept target and create copies of them for the LEA. It will also need to see any session management protocols that are used in your network to establish and maintain the communication sessions for each customer. This includes the protocols that you would use for AAA, such as Radius or GTP, as well as the SIP for intercepting any voice over IP calls. These protocols allow the LI system to know which IP address, and in the case of voice over IP, which ports, are being used by the intercept target, and therefore the system will be able to filter the IP traffic that it sees to only include packets sent or received by the target. From these packets, the LI system will generate the intercept records that will be sent back to the requesting LEA. These records will include any communications that were sent either to or from the interception target, but may also include supporting metadata that adds additional context to these communications. The metadata is usually derived from the session management protocols that are fed into the LI system and is often used to corroborate or validate the evidence provided by the intercepted communications themselves. For instance, the metadata for IP intercepts may include when the user logged into the network, what IP address they were assigned by the ISP, and which physical location the user logged in from. In the case of intercepted voice over IP calls, the metadata would also describe who the other party to the call was, who initiated the call, and how the media for the call was encoded. All of this information is useful supporting detail when presenting an interception as evidence in court. So let's take a bit of a peek inside the Magic LI box. If you've spent any time reading any official documents or standards about lawful intercept, then you may have come across a diagram that looks somewhat like this one. As you can see, there are a lot of acronyms and technical sounding terms on the diagram, and I'll explain what those mean shortly. The LI system itself is represented by the magenta colored box, and the components shown in that box demonstrate the specific functionalities that are required for an operator to have a working LI deployment. The blue box on the right shows the entities within the LEA domain that the operator's LI system will need to interact with. And the arrows between the two boxes represent the communication channels between the two systems, while the arrows within the operator domain represent the passage of instructions or captured records between individual components within the LI system. So it looks rather complicated, alright? But don't worry, we're going to break this down into smaller individual parts, and I'll try to explain each one of these in turn. But don't hesitate to flick back to this diagram as much as you need to while we go through this. It may look complicated at first glance, but it's really just a matter of figuring out what the acronyms and the jargon actually mean. We're going to start with the two most prevalent acronyms in the LI terminology, the CC and the IRI. CC stands for either content of communication or communications content, depending on who you ask. And a CC is a packet sent by or to an intercept target that has been intercepted by an LI system. For an IP intercept, the CCs are any IP packets that have the target's IP address as either source or destination. For a voice over IP intercept, the CCs would be any intercepted RTP or RTSP packets that belong to an intercepted call. Intercept-related information, abbreviated as IRI, refers to the metadata records that we described earlier, which must accompany the intercepted CCs. As mentioned earlier, the IRIs are derived from packets observed for session management protocols, such as Radius or SIP, and provide additional supporting information about the communication that may not be readily available in the CCs. IRIs can also be used to corroborate that the CCs are indeed part of a communication that was made by the intercept target. You can think of CCs and IRIs as the two types of output produced by an LI system. The CCs are the actual communications that were performed by the targets while the intercept was ongoing, and the IRIs are supporting metadata for that intercept. Now let's take a look at the mediation functions, of which we have two in our diagram, one for the CCs and one for the IRIs. Mediation function is really just a fancy way of saying takes some output and sends it to the intended destination. When the LI system produces a CC from an intercepted packet, that CC is passed to the CC mediation function, which knows which LEA is supposed to receive that CC. The mediation function then forwards the CC to the destination LEA over an established communications channel, which is typically called HI3, and uses a well-defined protocol format. And that's really all there is to it. In many ways, you can think of the mediation functions as glorified routing entities. They take intercept output and they forward on to the appropriate LEA. It's that simple. The Law Enforcement Monitoring Facility, or LEMF, is another convoluted term for a relatively simple concept. It really just refers to the place where the LEA wants you to send your CCs and IRIs, and it will likely be the entry point into another magic box that the LEA has paid a lot of money for, which takes the intercept records that your LI system produces and reconstructs them into usable evidence. This might be audio files containing a telephone call that took place, a reconstruction of a website that a target was browsing, or a chat log, just to give a few examples. The CCs and IRIs are generated by the internal intercept function, or IIF. The IIF is some software that runs either on or alongside your core networking equipment, observing the packets that traverse your network and identifying any that should be intercepted to produce either CCs or IRIs. Usually the IIF will need to be able to track session state for each network user so that it can readily associate any observed IP packets back to the user that they belong to and make sure that that user is an intercept target. The session state tracking is also required to correctly generate IRIs for the target session. The OpenLI collector software is an example of an IIF that runs alongside your networking equipment. You install the OpenLI collector on a separate server and then mirror interceptable traffic and the session management protocols from your routers into the OpenLI server. This has the advantage that much of the performance impact of interception is moved away from your core routers, aside from the cost of mirroring the traffic. The downside, of course, is that you have to dedicate ports on your routers for traffic mirroring, and that mirroring needs to be actively configured and managed. I'll touch more on intercept functions that run directly on your networking equipment a bit later on. The IIFs and mediation functions are controlled by the administration function, or AF. This function will receive intercept orders from the LEAs and turn those into instructions that can be pushed out to the other components within the operator domain. For IIFs, these instructions will include the identity of the intercept target and any labels that need to be added to any records captured as part of that intercept. For a mediation function, the instructions will tell the mediator which LEA needs to receive the results of the interception. For many LI deployments, the administration function may include some non-automated elements, such as verifying the validity of the received interception order, or updating the mirroring configuration on routers to ensure that all target traffic can be seen by an IIF. The last concept I want to introduce here is the handover, which is simply a communication channel between the operator and LEA. There are three handovers that are explicitly defined for an LI system, which are imaginatively named Handover Interface 1, Handover Interface 2, and Handover Interface 3. Handover Interface 1 is the method by which an operator will receive an interception order from the LEA. How HI1 works in practice will be determined by the LEAs that you have to deal with. This could be a physical handover of a paper warrant, or an email with a digital copy of the warrant attached. And usually someone employed by the operator will need to examine the interception order and confirm that it is valid before it can be entered into the administration function, so often the process cannot be fully automated. Handover Interface 2 is used to deliver the intercepted IRI metadata records to the LEA, and Handover Interface 3 is used to deliver the intercepted CC records to the LEA. The formatting and delivery mechanism used by these two handovers will depend on the LI standards that are supported by the LEAs, but will almost certainly require some level of encryption to be applied to anything that is transmitted via these handovers. There are two widely recognized sets of standards that govern the process of lawful interception and the method of delivering the intercepted content to the LEAs. These are the CALEA standards, which are used in the United States, and the ETSI standards, which are used almost everywhere else. Russia also has its own separate standard, known as SORM. The important thing to know about all of these standards is that they require the operator to go above and beyond the approach of simply TCP dumping a customer connection and sending that PCAP file to the LEA afterwards. The standards are designed to ensure that the interception contains sufficient information to withstand scrutiny in court, and the associated metadata that would otherwise not be present in a PCAP assists with this. But the standards also require that every intercepted record must be accurately labeled and sequenced, so that there can be no doubt that the full communication was intercepted. Another obvious benefit of having clearly defined standards is that the developers of LI systems can know the expected format of any output produced by their system, and both operators and LEAs can then purchase LI equipment under the expectation that if it is compliant with a given standard, then there should be no interoperability problems between the handovers. The last point I want to make about these standards is that they all specify that operators must be able to deliver the intercepted content to the LEAs in real time. With a PCAP-based system, an operator must complete the TCP dump capture before the file can be uploaded to the LEA. In situations where the LEA investigation is time sensitive, such as an ongoing kidnapping scenario or in the immediate aftermath of a terrorist incident, the PCAP approach is not particularly helpful. Therefore, real-time delivery is an essential requirement for LEAs, and this is reflected in the modern LI standards. Never expect an LEA to be happy if you offer to send them a PCAP in response to an interception order. While having clearly defined and detailed standards is a huge benefit from the perspective of the LEAs, it can be a bit problematic for the operators. The extra detail and requirements means that the implementation of those standards becomes quite a complex task, and the likelihood that an operator would have the resources available to develop a fully compliant solution in-house is extremely low. Most operators are therefore forced to look at buying an existing third-party system to meet their LI obligations. Of course, choosing an LI system is a challenge in itself, especially when you're not an expert in the field, and there are a number of factors that come into play when trying to make this decision. Budget is obviously a big one. Many of the commercial grade LI solutions are very expensive and may simply be unaffordable for small operators, but there are other things that you may need to consider, such as firstly, the level of support that you're expecting and willing to pay for from your LI vendor. Secondly, the LI standards that are supported by the system being considered, as some LI systems may only support the ETSI standards and others may only support the CALIA standards. And thirdly, whether you are confident in the security capabilities and the trustworthiness of the manufacturers of the system. Obviously, the last thing you want is to introduce a security vulnerability that allows unauthorized parties to be able to use your intercept infrastructure to spy on your customers. We should also note that these factors also apply equally if you happen to be a law enforcement agency and are looking to purchase a system for receiving and processing intercepted communications. So back to thinking about where we would acquire an LI system from. The first and most obvious option is to buy a commercial solution from one of any number of companies that are specialist lawful interception vendors. You can expect a system that you buy from these vendors to be standards compliant, well supported, and have complete functionality, including functions for mediation and administration. Well, probably. I mean, there's could be some dud vendors out there, as with anything, but if you stick to the well-known ones, you should be okay. The downside is that this will all come at a fairly eye-watering cost, both in terms of initial installation costs and ongoing support fees. If you're a large carrier with the money to spend and expect to be required to perform enough interceptions to make it worthwhile, then a commercial grade solution is definitely a good option for you to consider. Another option that may come up when researching LI systems are the licenses for LI that you can purchase for your existing networking hardware. Cisco, Juniper, Nokia, and undoubtedly many others offer these licenses to enable your equipment to quote-unquote perform LI, which no doubt sounds great to the unwary operator. The prospect of being able to simply purchase an additional license on equipment that you already own and have deployed and have your LI problem solved is very tantalizing. It's also very handy to have an IIF that runs directly on your networking hardware, rather than having to mirror your traffic to a separate device. But the LI capabilities offered by these licenses are often missing key features that you will still need to provide to have a fully compliant LI system. For example, the output format produced by these systems is often a custom protocol that's specific to that hardware vendor, and it won't conform to the LI standards that I mentioned earlier. The interception functions often do not produce IRI records, they only produce CC records, and in many cases the mediation function is missing and will still need to be provided by the purchaser. So really the LI features on your routers are only a partial solution at best, but because they are labeled as lawful interception in the sales brochures, operators in the past have fallen into the trap of buying these licenses only to find that they still have a lot more work to do to satisfy the LEAs that their interception system is fully functional. Having said that, if you can afford them, then the LI capabilities on these devices are actually very useful for mirroring the traffic for specific intercept targets into an IIF that will produce the suitable CC and IRI records. Your IIF would need to be able to parse and strip the custom protocols used by your vendor to encapsulate the intercepted packets in the right format. However, so this approach only works in very certain circumstances. The final option that we're going to talk about today, and presumably the one that brought you here in the first place, is OpenLI. OpenLI is open source software that is designed to provide an ETSI compliant, low cost LI solution for smaller network operators that cannot hope to be able to afford the commercial alternatives. To run OpenLI, you don't need much in the way of fancy expensive hardware, a small number of off-the-shelf 1U servers, and a DPDK compatible network card will meet the requirements pretty easily. We've had good success with getting OpenLI running in production on a number of networks within New Zealand and are now in the process of trying to take it to the rest of the world. The OpenLI source code is all freely available on GitHub under a GPL v3 license, and we also publish packages for several popular Linux distributions. One neat thing about OpenLI, which was a regular request from our initial users, is that it is able to understand some of those custom network vendor LI formats that I just mentioned and convert them into ETSI compliant CCs and IRIs. So if you already have access to those LI capabilities on your routers, then they may be able to directly interface with OpenLI. And that concludes this chapter of our OpenLI training series. Hopefully by now you have a very good idea of what lawful intercept is and how an LI system works in practice. You should be a lot more familiar with the various terminology that is used to describe the different parts of an LI system and how those components interact to satisfy an interception order from an LEA. You also should now have a passing knowledge of the technical standards for LI and be aware of some of the different options available when it comes to adding LI capabilities to your network. So join me in the next chapter where we're going to delve a bit more deeply into the ETSI standards to make sure that we properly understand what is required for an LI system to be fully compliant with those standards. I'll see you then.